This question asks us to rationalize why oxygen attacks carbon instead of bromine, going through pathway A instead of pathway B. There's a couple different ways we can rationalize this. One, if we look at the bromine atom that is being attacked, bromine has 2 bonds and 2 lone pairs. So it is it satisfies the octet rule at this point in the mechanism. If oxygen were to attack, bromine would still have 2 lone pairs. We don't have any arrows showing these lone pairs doing anything, and so that would end up being 10 electrons around bromine. Bromine would be violating the octet rule at that point. That's one reason. A better reason, perhaps, though, is to look at the carbon-bromine bond and consider the nucleophilicity and electrophilicity of each atom. In this step, oxygen is acting as a nucleophile. It's attacking something. It is the one with electron density, so it's going to attack something that lacks electron density. Looking at the bromine with the positive charge, you might think that the positive charge means that it lacks electron density, but that's not exactly true in all cases, and it's something that you want to watch out for. It's something that we'll see in a couple of different places that you want to watch out for. Just because it has a formal positive charge doesn't mean that it's the electrophilic atom. If we look at the bond between carbon and bromine, bromine is more electronegative. It's pulling more electron density towards itself. If we look at the actual electron density in this structure, the carbon atom is the electron poor structure. The electron poor atom, it has a delta positive. It is the one that lacks electron density. Bromine has more electron density than oxygen, even though it has a formal positive charge. Let me say it again. Bromine has more electron density than carbon, even though bromine has a formal positive charge. So when oxygen attacks, it will attack the most electron poor atom, and that would be the carbon atom rather than the bromine atom.